All right, welcome back. Hononegah, Algebra 1, Chapter 7 review guide. So this is the culmination of everything from Chapter 7. And Chapter 7 is one of the longest and most challenging chapters that we deal with. And so as we go through this review, I highly recommend you guys looking at this. I know we're going to do a lot of reviewing in class and stuff like that over the next few days. But I, again, highly recommend watching the video and going through the problems that you don't understand. So here we go. Identify the degree of the polynomial classified by the number of terms. I also wanted you to put it in standard form. Standard form means that it's in descending order from highest degree to lowest degree. And so this is what we did when we actually did this section, is we put things in standard form. Then the degree is the highest power. So in this case, it has a degree of 2 because we have an x squared. That's the highest one. And then the lead coefficient is the number in front of the highest powered variable. And then classify, because there are 3 terms, it's called a trinomial. So the next one actually is already in standard form, so I didn't have to change that at all. The degree is 3. The lead coefficient is 2, and because there are 2 terms, it's a binomial. So I know I did more than what we was in the directions, but that is all the different things that we talked about when we in section 7.1. Then also in section 7.1 is about adding like terms. And notice that there's a plus sign in the middle. So please be cognizant of the fact that there's an addition sign there. And so I'm looking for like stuff. And when I add like things together, I do not change the variable and I do not change the power. So the negative 3x cubed, there is nothing that's alike with the negative 3x cubed. So notice that I didn't change that at all. But negative 7x squared and 1x squared make negative 6x squared. And again, I like to cross them off as I go, so I make sure that I don't miss anything. And then a plus 2x and a minus 3x make a negative x plus 5. And so the next one, negative 6x, so that would be the first 2, and then positive 7, that would be the second 2. Subtraction does add a little bit of degree of difficulty. Here's what I highly recommend to anybody that is doing a subtraction question, is that I change it to a plus and then change all the signs. What that is doing is distributing the negative sign. So a positive 3m squared, a minus 5m, and a plus 7. So now I add the like ones together. Notice that 5m squared and 3m squared are alike. So I add them together because they have the same letter, same exponent. Positive 5m and negative 5m actually just cancel each other out, so I don't need that one. And a plus 16. So I would hit pause on this one and see if you can do it without me. All right, welcome back. So 8x cubed minus 7x. I'm going to change it to a plus sign, and then change all the signs of what you're subtracting, and then add the like stuff together. So 8x cubed has nothing that's alike. Negative 5x squared has nothing that's alike. A negative 7x and a negative 1x make negative 8x, so those two. And then a plus 1 has nothing that's alike. So again, I highly recommend changing it to a plus sign. Adding is much easier than subtracting. Distributing, now we're going to multiply. So in this case, I have a binomial, a single term, times a polynomial. So I'm going to multiply this to each one. Now remember, when you're multiplying, now the exponents do change. We have exponent rules. So negative 3x to the second times x to the third makes x to the fifth. Notice that I added the exponents. When multiplying, add exponents. So negative 6x to the fourth, I multiply the number, add the exponents. Multiply the number, add the exponents, and then it's just multiply the number because there is no change in the exponent. A binomial times a binomial is referred to as FOIL, first, outer, inner, last. So I take the first ones and multiply, the outer ones and multiply. And I'll do the arrows differently there. First one and the outer, the inner, and the last. And then I add like terms. Next one. This one is a binomial times a trinomial. So you're going to take the x times all 3. And then you're going to take the 3 times all 3. oops, 24. And then add any of the like ones together again. So I have x cubed, 8x squared. And remember, when you're adding and subtracting, you do not change the letter. So 8x and 15x plus 24. Back to foiling again. So if you want to hit pause and try this FOIL by yourself, see if you can get it right. First, outer, inner, and last. Add like terms. Anytime you have a binomial being squared, you're actually taking the binomial times itself. Then FOIL. First, outer, inner, and last. Now, there is a pattern to this, and we did discuss the pattern slightly, but I do not necessarily recommend you doing the pattern. I just recommend you FOIL. Same with this one. There is a pattern to be had here. When I do the outer and I do the inner, the outer and the inner are going to cancel because what you have there are conjugates. They're opposites of each other. N plus 1 times n minus 1. So because they're conjugates of each other, or opposites of each other, the middle term will actually cancel. A couple more FOIL questions. So again, first outer, inner, last. So 49x squared plus 14x. Again, the inner and the outer, because these are conjugates of each other, are going to cancel. So when I add like terms, I just get the first and the last. And then the last one, because you are taking a binomial and squaring it, you're going to multiply it times itself. So again, first, outer, inner, and last. Now we're getting into factoring, and this was the major part of our chapter here. And so the first thing, and it's going to tell you everything in the directions. I want to say this on the test. It's going to be very specific as to what they want. So it says factor by finding the GCF. GCF means I'm going to take out the highest number and or letter that is divisible into both, and then I divide by that number. So I divided by 3 and took away 1x. I divided by 3 and took away 1x. Just do what the directions ask of you. So the next one, and I'll be honest, this is one of the most missed ones. 2 is a common factor. 3 is a common factor, but 6 is the greatest common factor. So again, it's not just about taking out a common factor, it's about taking out the greatest common factor. Notice it says factor by finding the GCF. So again, I'm looking for something that's divisible into all of them. And so I could take out a 5 and x squared from both. So it's dividing by 5 and taking away 2 x's. Dividing by 5, taking away 2 x's. And dividing by 5 and taking away 2 x's. And the last one, 3x is the common denominator, or common factor. So if I divide by 3 and take away 1x, the next one, if you ever take out the entire function, like you're dividing by 3 and taking away 1x, leave a 1 then in its place, because again, 3 divided by 3 would be 1. Directions now. Factor the trinomial with an a value of 1, meaning there's no number in front of the x squared. So you are going to do factors of 26 that would get you 15. So two things that'll multiply to be 26. So I'm going to do 2 times 13. And so x plus 2 and x plus 13. So notice that the x squared got broken down into x times x, and then factors of 26 that would get you 15 are 2 and 13. So the next one, no number in front. So I'm stressing that. There is no number in front of the x squared. So how I factor that is different than how I would factor something that does have a number in front. So factors of negative 14, that would get you negative 5, would be negative 7 and 2. And then I turn those into my factors, my parentheses. Continuing, no number in front, but it's got to add up to, multiply to be negative 11 and add up to be 10. So it's not just things that multiply to be 11, and it's not just things that add up to be 10. It has to be both. So it multiplies to be negative 11 and also adds up to be positive 10. And so the signs matter. So when I'm trying to find two things that multiply to be 135, but also have to add up to be 1/3 or add up to be negative 24, I still need the fact that I am multiplying a negative times a negative, gets me a positive, but adds up to be a negative. And those of you that may not have known your times tables, 135 is 15 times 9. And let's say I didn't know that. Let's say, you know what, I didn't know that 15 times 9 was 135. Well, here's what I recommend. Start with 1. Divide by 2. Divide by 3. 3 goes into that 1 45 times. Divide by 4. Divide by 5. Divide by 6. Divide by 7. Divide by 8. Divide by 9. And now I've said, oh, look, 9 and 15. That would work for me. Next one. Now we're going to put a number in front. And this is where really the things started to turn for some people and whether or not you really understood what was going on or not. There are 2 ways to do this question. So I literally am going to do this question in 2 different ways. And there's more than 2 ways. It's just 2 ways that I've taught you. I need 2 things that'll multiply to be 7x squared. So this is an absolute guess, but I'm going to say 7x times 1x. That's what goes in the front of the parentheses. Another guess. Ways to get 1. Negative 1 times negative 1. Check your inner, meaning I multiply the 2 on the inside. Multiply your outer, so I multiply the 2 on the outside. If they add up to the middle, you guessed correctly. So that is one way of doing it, sheerly guessing and checking. The other way is to multiply the outside 2 numbers together, and the sign does matter. So positive 7 times a positive 1. So there were people in my class that struggled, and they didn't actually put the sign for that. 2 things that multiply to be 8, but add up to be 8. Hold on a second. I apologize. Multiply to be 7 and add up to be 8. So I multiply the outside 2 numbers together. I apologize. I was worried about the symbol and not worried about the actual multiplication. Multiplies to be 7, but adds up to be 1. And then I rewrite the question using those 2 numbers as my middle term. So this negative 7x and this negative 1x. Now it's a grouping question. So I take a 7x out of the first 2, a negative 1 out of the second 2, and I grouped. So notice that I get the exact same answer in both ways. I apologize. When I multiply the outside 2 numbers together, I messed that up. So we'll keep going. I'll do the next one, again, in 2 different ways. Hopefully I won't make a mistake this time. So 2 things that multiply to be 6. 2x and 3x would be a guess. 2 things that multiply to be negative 5 would be a positive 5 times a negative 1. Order at which you do this does make a difference, and the signs make a difference. So when I multiply these 2 together, I get 15x. When I multiply these 2 together, I get negative 2x. And when I add them up, I get 13x, and therefore I did it right. Next one, I'm going to multiply the outside 2 numbers together, and the sign does matter. So I need this positive 6 times a negative 5. So now 2 things that'll multiply to be negative 30, but they have to add up to be 13. Rewrite the question. So what can I take out of the first 2? I can take a 3x out of the first 2. I can take nothing out of the second 2 except a negative 1. And so I group I group the GCF and keep what's the same. And you'll notice that I got the exact same answer in reversed order, but that's okay. The only reason it's reversed is because I went 15 minus 2. If I'd have went the other way around, negative 2 plus 15, then I'd have gotten it exactly the same. So next one. Factors of 12. This is where things start getting a little bit more challenging for some individuals because ultimately there are 1 times 12, 2 times 6, 3 times 4, and I'm going to try 3 and 4 as being my guess. Negative 3, there's not a lot of ways to get negative 3. Negative 3 times positive 1 is really kind of one of the only guesses that you're going to have. And so positive 4x, negative 9x does add up to the middle. So there's guess and check. Multiply the outside two numbers together. Again, the sign does matter. Two things that'll multiply to be negative 9, or excuse me, negative 36, but they got to add up to be negative 5. Rewrite the question. So now I can take a 3x out of the first two. Nothing comes out of the second two, so I just take out a 1, group the GCFs, and keep what's the same. Last one. I recommend you hitting pause right now. See if you can do this one by yourself. All right, welcome back. So I am going to do this in two different ways again. 3x and x are really the only ways to get 3x squared. Negative 4. Now there are some options here, like plus and minus, things like that. I'm going to go with a plus 2 and a minus 2, and I check it. Negative 2x, negative 6x, positive 6x adds up to positive 4x, so I did it right. This way, I'm going to multiply the two numbers together. Factors of negative 12 that add up to positive 4 would be positive 6 and negative 2. Rewrite the question. Take the GCF of the first two, GCF of the second two, group the GCF, and keep what's the same. Difference of squares. This is a very, very, very specific type of factoring. First of all, it has to be a binomial, so there's two terms. Second of all, the first one has to be a perfect square, and the second one has to be a perfect square, and it has to be a minus sign. So this qualifies. The first one is a perfect square. It's x and x. 225 is a perfect square. It's 15 times 15, and so one of them's plus and one of them's minus is the pattern here. So the next one, perfect square, 8x times 8x. 3 and 3. So again, this is a very specific type of factoring. It's called the difference of squares. They have to be two squares and a minus sign. Factor by grouping. We've actually already done grouping when I did trinomials with the lead coefficient, so this should be a review of those people. I can take an x out of the first two. I can take a y out of the second two, group the GCF, and keep what's the same. And so in the next one, I can take an x squared out of the first two. I can take a negative 6 out of the next two. So again, I'm dividing out a negative 6 from both of those. Group the GCF and keep what's the same. And the question I always get is, will it always end up being the same? The answer to that question is yes. In order to do factor by grouping, when you take the GCF of the first two and the GCF of the second two, it does have to get the exact same parentheses. So if it doesn't do that, then you probably made a mistake somewhere. Now for the big one. Now for it, we're going to put them all together now. It's factor completely, and I want to stress the directions here is telling me what I should do. Basically, take the GCF out first, then look to factor again. So I see that there is a GCF of 2x. So I'm going to take a 2x out of both of those. Now, what's inside the parenthesis, and I'm going to underline it here, can be factored again. It's the difference of squares. X and 6 and 6 make 36. So it's the difference of two perfect squares. Do not forget the GCF when writing your answer. So again, take the GCF out first, then continue to factor. And this is exactly what the directions, it's going to tell you basically what you need to be looking at. So take out the GCF. So 3x is divisible into all of these. Now, factor what's inside the parentheses. I need factors of 24. That would add up to 11. And so x plus 8, x plus 3 is the factoring of x squared plus 11x plus 24. And then don't forget the GCF when writing your answer. GCF first, so it's divisible by 5. Now, look what's inside the parenthesis. I can factor that. Two things that multiply to be 4, but add up to be -4. And don't forget the GCF. Now, I'll accept this answer, and I think all the teachers will accept that answer. You technically could write the answer this way because the two parentheses end up being the same. And so the last one here, or the last one in this page, take out an x. So I'm taking out the GCF. Factors of negative, remember there's no number in front of the x squared. Everything changes if there is a number in front of that x squared. Just factors of -18 that also add up to 7. That will create your magic numbers. That'll create the numbers that work. And then don't forget the GCF when writing your answer. Solving now, and here's the thing that basically once it's in factored form, and I'm going to stress that once it's in factored form, set the factors equal to 0. So anywhere where there's a variable, right, that's in factored form. So I have an x equals 0. This one's already factored for me. X minus 8 equals 0, and 5x plus 1 equals 0. So again, if it is in factored form, set the factors equal to 0 and solve. And so the question then becomes is what do I do when it is not in factored form? First, I need it to equal 0, so that is my first step here. And then second is to actually factor it using all the methods that I have learned this chapter and all the review questions that I've been doing. So how do I factor a trinomial with no number in front? I need factors of -30. That would add up to 7. So there's the factoring portion. Now for the solve portion. X minus 3 equaling 0, and I solve it. X plus 10 equal to 0, and I solve that. So again, how do I solve questions? First I factor it, and then I set the factors equal to 0. Difference of squares. X minus 5 and x plus 5. X squared is a perfect square, x times x. 25 is a perfect square, 5 times 5. And I factor. To solve, I would set the factors equal to 0. And so I get x equals 5 and x equals -5. So now 38 is about as hard as, sorry for the interruption there, as challenging as I can make this. First, there is a GCF. That is always the first thing I should be looking for, or something that can be divided into and taken out of all of them. So I'm dividing by 2 and taking out a x. What's left has a lead coefficient. So again, this is as challenging a problem. If you want to put a star by something, this is the top of the mountain here. I have to factor what is inside the parenthesis. I'm only going to do this one in one method this time. I'm going to do just guess and check. So I'm going to do 2x and x. And then I need factors of 7. So I'm going to do 7 and -1. I'm going to check it. And it does add up to the middle. So if you are not a guess and check person, obviously you would need to do that in another method. All right. Solving now. So once I have it in factored form, set the factors equal to 0 and solve it. So I subtract 7 from both sides. Here I'm going to divide by 2 and get x equals 0. And in the middle, I'm going to add 1 and divide by 2 and get x to be 1/2. So this is as hard as I can make it. You have to take out a GCF, and you have to factor something that has a lead coefficient. So again, that is the most challenging I can make it. Next one. Grouping. 2x squared comes out of the, oops, let me try that again. Just x squared comes out of the first two. So I'm left with 2x plus 3. -4 comes out of the next two. And so this is a really cool question. After I get done with my grouping, I see that I have a parenthesis that actually can factor again. It's the difference of squares. So x and x, 2 and 2, one's plus and one's minus. That's the factoring portion of this. Now let's get into the solve question. I set the factors equal to 0, and I solve. So I add 2 to both sides, subtract 2 to both sides, and get x is equal to -3/2. Last question. In order to solve this, I need it to equal 0. So I subtracted 12x over. GCF of 3x. And that's it. There's only a GCF here. That doesn't mean I still can't factor it or I still can't solve it. Once it's in factored form, I set the factors equal to 0. That's a 0, by the way. Set the factors equal to 0 and solve. And so that concludes our review here. Hopefully you got, I believe, I don't think there's another one. If you have any questions, go through this again, watch it again, make sure that you're prepared for each section here. If you have questions, make sure you talk to your teacher. Good luck. Again, this is one of the more challenging sections, so hopefully you're spending some time studying this. And good luck to all of you.